You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. The purpose of this episode is to explore memory methods that make learning more durable and exam-ready. Many learners believe that time spent reading or listening automatically translates into retention, but without deliberate techniques, the brain forgets quickly. Memory is not a single process. It is an interplay of encoding, storage, and retrieval. Encoding is how information first enters the mind, storage is how it is maintained, and retrieval is how it is later accessed. Each step can be strengthened with the right strategies. For CCSP preparation, this means not only hearing the material but actively working with it, rehearsing it, and connecting it to what you already know. The techniques in this session turn passive exposure into active learning, so that knowledge is available under the pressure of timed exam questions and transferable to real-world problem-solving. Memory architecture begins with encoding, the stage where information is transformed from sound or sight into meaningful patterns. If encoding is shallow, such as skimming without attention, the trace left in memory is weak. Deep encoding involves linking new ideas to existing structures, which makes them easier to store. Storage, the next step, involves keeping this encoded information available over time. Without reinforcement, storage degrades, leading to forgetting. Retrieval is the final stage, and it is also the most important for exams. It is not enough to know something unless you can pull it out when needed. Weak retrieval often feels like knowing the answer on the tip of your tongue, but failing under time pressure. By strengthening all three stages, you improve the reliability of recall when it matters most. Active recall is the practice of retrieving information from memory without looking at prompts. Instead of rereading notes, you cover them and ask, "What does this term mean?" or "How would I explain this principle?" The struggle to recall strengthens memory traces, much like lifting weights strengthens muscles. Even partial recall improves long-term retention because the act of reaching into memory reinforces the pathways. This is why quizzes and flashcards work so well. They force recall rather than recognition. In CCSP study, active recall might mean listening to a segment, then pausing to summarize aloud in your own words. It feels harder than passive review, but that difficulty is the signal that memory is being strengthened. Spaced repetition takes advantage of how memory fades over time. Instead of reviewing content once and hoping it sticks, you revisit it at increasing intervals, 1 day later, then 3 days later, then a week later, and so on. Each review restabilizes the memory just before it slips away, making it more durable. Think of it like watering a plant. Too often and you drown it, too rarely and it withers. The right intervals nurture long-term growth. For audio learners, this might involve replaying specific prepcast segments on a rotating schedule or tagging glossary terms for revisits at set times. Spaced repetition ensures that by the time you reach exam day, critical concepts have been encountered enough times to feel natural and automatic. Interleaving is the practice of mixing different topics during study sessions, rather than focusing on a single subject for long stretches. At first, it feels less efficient because switching topics demands effort, but this very effort strengthens your ability to distinguish between similar concepts. For example, alternating between encryption methods and identity management practices makes it clearer how they differ, reducing the chance of mixing them up on the exam. It is like practicing both forehand and backhand strokes in tennis during the same session, harder at first, but ultimately more effective. Interleaving keeps study varied, prevents fatigue, and mirrors the reality of the exam, where questions from all domains are interwoven. Elaboration builds stronger connections by linking new information to what you already know. Instead of memorizing a fact in isolation, you explain it in full sentences and tie it to familiar examples. For instance, when learning about tokenization, you might elaborate by connecting it to the way credit card numbers are replaced with stand-ins to reduce risk. This process deepens encoding and makes recall easier because the idea now lives in a richer network of associations. Elaborated knowledge is like a tree with many roots. It can be accessed from multiple directions, increasing the chance of retrieval. In practice, elaboration transforms rote memorization into meaningful understanding that endures beyond the exam. Dual coding strengthens memory by combining verbal descriptions with mental imagery. In an audio-first context, this does not mean drawing pictures but creating mental images to accompany verbal explanations. For example, when hearing about layered defenses, you might picture a castle with multiple walls and gates. When listening about encryption, you might imagine a locked box passed along a chain. These mental visuals anchor the words, making them easier to remember. Dual coding works because the brain processes images and words through different channels, reinforcing memory through two pathways instead of one. By practicing this technique during prepcasts, you turn abstract descriptions into vivid, memorable experiences. Effective note-taking is not about transcribing everything but about capturing signals rather than noise. Notes should highlight the key terms, definitions, and insights that serve as retrieval cues later. Writing too much creates clutter that is hard to review, while writing too little leaves gaps. The goal is to record enough to jog memory without drowning in detail. For CCSP preparation, this might mean writing one-line summaries after each audio segment, focusing on the main principle. The process of selecting what to write is itself a form of learning, because it forces you to evaluate what truly matters. Notes then become tools for reinforcement rather than burdensome scripts. The Cornell Notes method offers a structured way to capture information. A page is divided into 3 sections: a wide note-taking column, a narrower cue column, and a summary area at the bottom. During study, you record main points in the notes area. Later, you generate prompts or questions in the cue column, which help drive active recall. Finally, you write a short summary that condenses the material. This format transforms notes into a self-testing system. Instead of passively reviewing, you cover the notes and use the cues to practice recall, then check accuracy against the details. The Cornell method encourages organization, reflection, and retrieval, all crucial for durable memory. Building a personal glossary reinforces mastery of acronyms and terms, which are abundant in cloud security. Each time you encounter a new term, define it in your own words and record it. For example, CASB Cloud Access Security Broker, a tool that enforces policies between users and cloud services. Writing definitions in your own language strengthens encoding, while revisiting the glossary periodically strengthens retrieval. This glossary becomes a quick reference guide, but more importantly, it reflects the process of turning jargon into accessible knowledge. Over time, reviewing the glossary ensures fluency with terminology, reducing cognitive load during the exam, and freeing mental energy for reasoning. Error logs are another valuable tool. Each time you miss a practice question, capture the item and the reason for the error. Did you misunderstand a term? Did you misread a qualifier? Did you confuse two similar concepts? Writing down both the mistake and the correction transforms errors into lessons. Reviewing this log periodically highlights patterns and weaknesses and ensures they are addressed. Instead of discouragement, errors become opportunities. The log also builds confidence over time, as you can see past mistakes resolved through learning. Much like incident logs in security operations, error logs create visibility into what went wrong and guide improvement. Retrieval practice sessions build on active recall by using prompts to trigger full explanations from memory. A prompt might be a single word like tokenization or shared responsibility. From that seed, you attempt to recall the full definition, examples, and implications. The key is not just stating the term but explaining it as if teaching. This expands the recall process, strengthening connections across domains. Practicing retrieval this way ensures knowledge is not just surface level but integrated, able to be applied in varied contexts. The more often you can reconstruct information from small prompts, the more exam-ready you become. The generation effect describes the phenomenon that producing an answer yourself leads to stronger memory than simply reading or hearing it. For instance, if you fill in the blank of a partially remembered sentence, the effort of generating the missing word makes it more memorable than passively rereading. This is why flashcards are more effective when you attempt an answer before flipping to the back. In CSP study, you can harness the generation effect by pausing audio segments to anticipate definitions or outcomes before hearing them. This proactive engagement makes learning more durable because you are not only receiving but also producing knowledge. Desirable difficulties are study activities that feel effortful but improve long-term retention. Active recall, interleaving, and generation are all examples. They may feel harder than rereading or highlighting, but the struggle signals deeper processing. It is like exercising with resistance. The weight feels heavy, but it is what builds strength. Learners often avoid these methods because they feel less comfortable, but embracing the discomfort leads to greater payoff. By designing study sessions to include desirable difficulties, you maximize long-term retention, even if short-term ease is sacrificed. This mindset shift helps you view difficulty as a friend rather than a foe in your learning process. Cognitive load theory explains that working memory has limits. When too much information is presented at once, overload occurs and retention suffers. Effective study design respects these limits by breaking content into manageable chunks, sequencing topics thoughtfully, and alternating heavy with light tasks. For audio learning, this means segmenting content into sessions of manageable length and pausing to process before moving on. It also means avoiding distractions, since multitasking drains limited cognitive resources. Understanding cognitive load helps you design study that is challenging but not overwhelming, pushing the boundaries of memory without exceeding them. This balance is key to building durable, exam-ready knowledge. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. A spaced repetition system, or SRS, is one of the most effective tools for reinforcing knowledge over time. These systems use algorithms to determine the optimal moment to review material just before you are likely to forget it. Each time you recall an item successfully, the system schedules it further into the future, building durability. If you struggle, the system brings it back sooner. Think of it as a personal trainer for memory, adjusting the weight of each review session according to your performance. For CSP study, SRS software or even a simple calendar-based system ensures that you do not rely on random revisits but follow a plan tailored to your own forgetting curve. This method makes sure that every key concept remains alive in memory until exam day. Closed deletion cards are a powerful flashcard type within SRS. Instead of asking for a definition outright, they present a sentence with a critical word removed. For example, the responsibility model explains how duties are divided between provider and consumer. This forces recall within context, which is more powerful than recalling terms in isolation. Closed deletions mimic real exam scenarios, where terms appear within explanations rather than standing alone. They also encourage deeper processing, because you must understand how the missing word fits into the broader concept. Using closed deletions in your study repertoire strengthens contextual memory, which is essential when navigating questions that demand more than rote recall. Concept maps, adapted into text form for audio-first learners, offer another way to reinforce relationships among ideas. A concept map lays out how terms and principles connect data classification links to encryption, which links to key management, which ties into governance frameworks. For those studying primarily through listening, the exercise becomes verbal, speaking out loud. Encryption connects to data at rest, while key management connects to governance. These maps make knowledge relational rather than isolated, which mirrors how cloud security works in practice. By practicing connections, you are better prepared for exam questions that combine domains, such as tying operational monitoring to legal compliance obligations. Concept mapping transforms a list of topics into an interconnected web of understanding. Self-explanation is a deceptively simple but powerful technique. After encountering a fact or process, you pause and articulate why it is true or why it works that way. For example, instead of just noting that multi-factor authentication increases security, you explain, it reduces risk because a stolen password alone is insufficient to gain access. This method turns passive knowledge into active reasoning. The more often you practice self-explanation, the more robust your recall becomes, because you have rehearsed the logic as well as the definition. For CCSP learners, this is invaluable, since many exam items test understanding of principles rather than surface-level memorization. Self-explanation ensures that when faced with scenarios, you can reason confidently rather than guess. Mnemonics are traditional memory tools, but when applied carefully, they remain useful for consolidating lists or sequences. A mnemonic phrase can capture the stages of the data lifecycle or the core principles of governance. The key is to design mnemonics that are memorable without distorting meaning. For example, to remember the lifecycle stages: create, store, use, share, archive, destroy, you might construct a phrase that cues each initial letter. Mnemonics act like scaffolding, holding information together until it is deeply learned. They are especially effective for sequences, where order matters, and for sets of terms that are easily confused. Used thoughtfully, mnemonics add efficiency to study without replacing deeper comprehension. First-letter mnemonics, such as acronyms, deserve special mention. They are best applied only after you already understand the underlying definitions. For instance, using CIA to recall confidentiality, integrity, and availability works only if you first know what each of those terms means. Otherwise, the letters are empty placeholders. Once definitions are mastered, acronyms compress them into quick cues that are easy to recall under exam pressure. This layering first comprehension, then acronym, ensures that the mnemonic supports memory rather than replacing true understanding. In professional practice, this also prevents the superficial recall of jargon without the depth required to apply it meaningfully. Encoding variability is another method that strengthens memory by studying the same content in varied contexts. This might mean listening in different places, at different times of day, or while engaged in different light activities like walking versus commuting. Each variation creates a new memory trace, broadening the cues available for recall. It is like leaving multiple bookmarks in a book. You increase the number of ways you can find your way back to the right page. Encoding variability counters the trap of context dependence, where knowledge is only accessible in the exact setting it was learned. By varying contexts, you ensure that recall is robust and flexible, ready for exam conditions. Retrieval spacing calibrates review intervals based on item difficulty and personal forgetting rates. Harder concepts should be revisited more frequently, while easier ones can be stretched further apart. This personalization maximizes efficiency, ensuring you spend energy where it is most needed. It mirrors triage in study. Allocate resources according to the severity of gaps. Many digital tools handle this automatically, but even without software, learners can categorize terms as hard, medium, or easy, and plan intervals accordingly. Retrieval spacing ensures balance, preventing overexposure to already mastered content while safeguarding weaker areas. This fine-tuning makes study sharper and prevents wasted effort. The lag effect explains why longer intervals between reviews often produce stronger retention than shorter, massed repetitions. Reviewing a concept an hour later feels comforting, but reviewing it a week later forces more effort, and that effort cements the memory more firmly. It is the difference between lifting a light weight often versus occasionally lifting a heavy one. Both build strength, but the heavier lift develops durability. For exam preparation, this means scheduling reviews far enough apart to feel challenging, not just reassuring. The lag effect can feel uncomfortable, but leaning into it ensures knowledge lasts through exam day and beyond. Consolidation windows highlight the role of sleep and circadian rhythms in memory. Short reviews before bed and brief refreshers after waking can significantly reinforce retention. The brain processes and strengthens memories during sleep, and reviewing content just before rest gives it priority in this consolidation. A morning review then reactivates the memory, cementing it further. For CCSP study, this could mean scanning glossary terms at night and revisiting them over coffee in the morning. These short windows act as multipliers, enhancing the durability of learning with minimal time investment. By aligning study with natural biological processes, you make memory formation more efficient. Note refinement is the process of transforming raw capture into structured summaries and prioritized highlights. Instead of leaving notes in scattered fragments, you revisit them to condense, reorganize, and emphasize key points. Refinement converts passive scribbles into active tools for retrieval. It forces you to decide what is signal versus noise, which deepens processing. For audio learners, this might mean recording short spoken summaries of notes after a listening session. The act of distilling information strengthens recall and produces cleaner materials for later review. Refinement is where notes shift from being records of the past to resources for the future. Successive relearning combines testing and restudy until accuracy stabilizes. Instead of reviewing once and moving on, you alternate recall attempts with corrections until you can reliably reproduce the information. This approach ensures mastery rather than mere exposure. It is like practicing a musical piece until you can play it smoothly multiple times, not just once by luck. Successive relearning may feel repetitive, but it guarantees reliability under exam conditions. For CCSP candidates, this method ensures that critical definitions, frameworks, and responsibilities are not only recognized, but consistently recalled, reducing surprises when similar terms are tested in different ways. Calibration checks align confidence with actual performance. Many learners overestimate their mastery, believing they know a topic because it feels familiar. By rating confidence on each recall attempt and then comparing it with accuracy, you reveal gaps. This prevents the dangerous trap of overconfidence, where comfort replaces competence. Calibration creates honesty and self-assessment, showing you which areas truly need reinforcement. Over time, it sharpens intuition about what you actually know versus what only seems familiar. This honesty is vital for exam readiness, where false confidence can lead to careless mistakes under time pressure. Transfer of learning ensures that remembered concepts apply across different scenarios. For example, understanding the shared responsibility model in theory is one thing, but applying it to a scenario about data encryption in a hybrid environment demonstrates transfer. This process strengthens knowledge by weaving it into multiple contexts. The more often you transfer, the more versatile your knowledge becomes. CCSP questions often require this flexibility, combining domains or reframing concepts in new ways. Practicing transfer prepares you for such items, ensuring your memory is not rigid but adaptable, capable of supporting reasoning in unfamiliar contexts. Metacognitive monitoring ties all these strategies together by keeping awareness of what you know and what you do not. It is the practice of stepping back, asking, how well do I understand this? How easily can I explain it? This monitoring prevents wasted effort and directs attention where it matters most. It is like a dashboard for your study journey, showing fuel levels and warning lights before breakdown occurs. In memory training, metacognition is the difference between drifting and steering. By maintaining awareness throughout the study process, you ensure that active recall, spaced repetition, and note-taking are applied where they produce the greatest impact. In summary, memory is not a matter of exposure but of method. Active recall strengthens retrieval, spaced repetition builds durability, and disciplined note-taking ensures clarity. Techniques like closed deletions, concept maps, elaboration, and calibration checks transform knowledge into something flexible, reliable, and exam-ready. By embracing desirable difficulties and managing cognitive load, you train memory to perform under real conditions, not just in practice. Together, these methods convert study into mastery, ensuring that CCSP concepts are not only known but usable, ready to be retrieved, applied, and trusted when the pressure of the exam demands it. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.